Hello friends, today we are going to start from Maths and Statistics Part 2, lesson number differentiation. This is the important chapter for the point of 12th standard. This chapter carries 16 marks. So differentiation is nothing but that is derivative. Differentiation is nothing but derivative, that is d by dx of n given function, that is the rate of change. So in this chapter we are going to study real value functions, limit of functions, continuity of functions at a point and over an interval. So you know that average speed when we are going from our village to Mumbai, then average speed of the car, that is total distance traveled, that is speed is equal to distance upon time, that is total distance traveled upon time taken to travel that distance, is nothing but the average speed. If the limit of this ratio as time interval tends to 0, that we have studied in limit. What is the mean of tends? That is we have to show by the arrow. Is the speed of the car at that time. Now, the rate of change in the function at point with respect to the variable is called as derivative of that function. And the process of finding the derivative is called as differentiation. So, definition of the derivative and differentiability. Let that is f of x be the function defined on an open interval containing the point a, that is open interval, that bracket limit delta x tends to 0, f of a plus delta x minus f of a divided by delta x exists, that is f is said to be a differentiable at x is equal to a, and f dash a is the derivative. Suppose y is equal to f of x be the function and small interval of the value x, say delta x. Similarly, y to delta y. So in both, that is both sides, we have to add small increments. Y plus delta y is equal to f of x plus delta x. Now delta y is equal to y, we have to interchange from left to right, f of x plus delta x minus y. But you know that delta y is equal to f of x plus delta x, the value of y is equal to f of x, so that's why we have to write minus f of x. As delta x a small increment, so we are dividing the both side by delta x. So delta y upon delta x is equal to f of x plus delta x minus f of x divided by delta x. Now we have to take the limit, that is delta x tends to 0. Then limit delta x tends to 0, delta y upon delta x is equal to limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x. Now we are going to take separate, that is if the upper limit exists, then limit corresponding value is called derivative of the function, and it is symbolically represented as dy by dx. So dy by dx is equal to, that is, f dash x. So here some note is there that we have to listen. If f of y is equal to f of x is a differential function of x, then limit delta x tends to 0, delta y upon delta x is equal to dy by dx, and limit delta x tends to 0, f of x plus delta x minus f of x upon delta x is equal to, that is, f dash x. Let delta x is equal to h. Suppose that limit h tends to 0, f of a plus h minus f of a divided by h exists. It implies that limit h tends to 0, f of a plus h minus f of a upon h is equal to limit h tends to 0, f of a plus a minus f of a divided by h. Limit h tends to 0, f of a plus h minus f of a upon h is called the left hand derivative, that is LHD at x is equal to a, and limit h tends to 0, f of a plus h minus f of a upon h is called a right hand derivative, RHD at x is equal to a. So that's why both sides we have written the same. So LHD at x is equal to represented by f dash a, or limit of f dash a, and RHD x is equal to represented by f dash a dash, or r of f dash a dash. Now we will study the derivative of some standard functions. Find the derivative of x raised to n with respect to x, n belongs to n. That is the direct, that is x raised to 1, that is the standard form, that is d by dx of x raised to n is nothing but n into x raised to n minus 1, by proving with proof, that is f of x is equal to x raised to n, f of x plus h is equal to x plus h bracket raised to n. By using the method of first principle, f dash x is equal to limit h tends to 0, f of x plus h minus f of x divided by h. So f dash x is the limit h tends to 0, x plus h bracket raised to n minus x raised to n upon h. That we are going to substitute f of x plus h and f of x. Limit h tends to 0, x raised to n plus nc1 x raised to n minus 1 into h plus nc2 x raised to n minus 2h square plus dash dash plus h raised to n minus x raised to n divided by h. Then x raised to n minus x raised to n get cancelled. Then we will get a limit h tends to 0, nc1 x raised to n minus 1 h plus nc2 x raised to n minus 2 x raised to n minus 1 x minus 2 h, then h square, then nc3 x raised to n minus 3 h cube plus dash dash x raised to n upon h. Now here h is a common. Limit h tends to 0, h into bracket nc1 x raised to n minus 1 plus nc2 x raised to n minus 2 h plus nc3 x raised to n minus 3 h square plus dash dash plus h raised to n minus 1 upon h. H's get cancelled. Limit h tends to 0, and c and x raised to n minus 1 plus nc2 x raised to n minus 2h plus nc3 x raised to n minus 3 h square plus h raised to n. As h tends to 0, h is not equal to 0. So if f of x is equal to x raised to n, f dash x is equal to n into x raised to n minus 1. Find the derivative of sine x with respect to x. F of x is equal to x. F of x plus h is equal to sine of a plus h. Method of first principle. F dash h limit h tends to 0. F of x plus h minus f of x divided by h. Substitute f of x plus h, that is sine of x plus h minus sine x upon h. So sine of a minus sine a minus sine b, that is 2 cos of 2x plus h upon 2 sine of h by 2 divided by h. Limit h tends to 0. Then 2 common, limit h tends to 0, cos of 2h plus h upon 2. Limit h tends to 0, sine h by 2 upon h by 2 multiplied by 1 by 2. Because h is there, we have divided by 2. So 2 divided by 2 is divided to h, that is the multiplied by whole function by 1 by 2. So 2 limit h tends to 0, cos of x plus h by 2, that is 2 is the common, 2 is divided to each and every term. So h plus x plus h by 2, limit sin h by 2 upon h by 2 into 1 by 2. So 2 cos x into 1 by 2. Limit h theta tends to 0, sin p theta upon p theta is equal to 1. So sin h by 2 upon h by 2, that is 1. So 1 into, that is x plus h by 2, that is 1 into 1 by 2. Here cos of x, as it is h is 0. So 2 cos x into 1 into 1 by 2. 2 get cancelled. So f of x is equal to sin x is equal to f of x, f dash x is equal to cos of x. Tan x. Next, limit x, that is, f of x is equal to tan x, f of x plus h is equal to tan of x plus h. F dash x, limit h tends to 0, f of x plus h minus f of x divided by h. Substitute, that is f of x plus tan of x plus h minus tan x upon h. So tan means sine upon cos. Sine x plus h upon cos of x plus h minus sine x upon cos x divided by h. So sine of x plus h cos x minus cos of x plus h sine x divided by cos of x plus h cos x divided by h. So limit h tends to 0, sine h upon h cos of x plus h cos x. Limit h tends to sin h upon h. Limit h tends to 1 upon cos x plus h upon into cos x. Sin h upon h is equal to 1 upon cos x into cos x, that is cos square x. So if f of x is equal to tan x, f dash x is equal to 1 upon cos square x is sec square x. Find the derivative of sec x with respect to f of x is equal to sec x, f of x plus h sec of x plus h. From the definition, f dash x is equal to limit h tends to f of x plus h minus f of x divided by h. F dash x, limit h tends to sec of x plus h minus sec x upon h. So sec means 1 upon cos of x plus h minus 1 upon cos x into h. By cross multiplication, cos x minus cos of x plus h divided by cos of x plus h into cos x. So limit h tends to 0, cos x minus cos of x, that is 2 sin 2x plus h upon 2 sin of minus h by 2 divided by h cos of x plus h cos x. 2 outside, minus minus become plus, minus 2 and minus h, that is plus 2 limit h tends to 0, sin 2x plus h upon 2 cos of x plus h cos x. Limit h tends to 0, sin h by 2 upon h by 2, again we have divided by 2, that's why multiplied by 1 by 2. So 2 sin x upon cos square x into 1 by 2. 2 get cancelled. So sin upon cos, that is tan, into 1 upon cos, that is sec. So f of x is equal to sec x, f dash is equal to sec x tan x. Find the derivative of log x with respect to x. F of x is log x, f of x plus h is equal to log of x plus h. From the definition of dash x, limit x tends to 0, f of x plus h minus f of x divided by h. F dash h, limit h tends to log of x plus h minus log x upon h. So here, log common, limit h tends to 0, log of x plus h upon x divided by h. Again, divided by x, limit x tends to log of 1 plus x, h by x upon h. Limit h tends to 0, log of 1 plus h by x upon h by x multiplied by 1 by x. So same function 1 multiplied by 1 by x, that is 1 by x. So if f of x is log x, f dash is 1 upon x. Now last example, find the derivative of a raised to x with respect to x. Let f of x is equal to a raised to x and f of x plus h is equal to a raised to x plus h. From definition f dash x, limit h tends to 0, f of x plus h minus f of x divided by h. F dash x is equal to limit h tends to 0, a raised to x plus h minus a raised to x upon h. A raised to x common by using the a raised to x plus, that is a raised to x into a raised to h. So a raised to x common, a raised to h minus 1 upon h. So a raised to x, that is outside the limit, limit h tends to 0, a raised to h minus 1 upon h. F dash is equal to a raised to x log a. That is when limit x tends to a raised to x minus 1 upon x is equal to log a. So f of x is equal to a raised to x, then f dash x is equal to a raised to x log a. So these all derivatives you are by heart and solve this example and send the picture of